using Kotlin. And I guess one of the things that you end up noticing is that it saves you a lot of boilerplate code. It makes your code safer. And then, for example, for Android, we've built a library called KTX with a lot of extensions. And then if you look at what's going on inside, you see things like this, with some magic keywords like inline. Or if you look at samples, you see stuff like this, with other keywords, like sealed. So it feels like Kotlin is a lot of magic keywords. So what I want to do today is to be the bad person that ruins all of that magic for you. I will not show you bytecode, because I like you. So I will show you decompiled Java code, because all of the stuff that Kotlin is doing is actually not that magical. It's actually not that magical. But you'll have to pay attention, because at one point, and you don't know when, there's going to be a quiz, and you better know the answers. OK. So I know that not all of you are Android developers, but humor me for this. It's just a simple example, I promise. So let's say that we want to display a list of users. So we would have a data class that holds the name of the user and whether the user is active or not. Because depending on that flag, we want to show an item, the user being disabled. But we also want to handle the click on the user. Let's say that when we click on the user, we want to disable it. So this means that we would have to create something like an interface that handles the clicks. And then when we want to display the user, we could create something like a user model that would also get the user, but also that listener, so something would know how to implement it. And then when we implement it, we end up having to write something like this, which is a lot of code, and I am lazy. So Kotlin allows us to pass functions as parameters. So these would work as the normal value parameters. And then when we're using it, we can just write a lambda where we implement that function. And then also, functions can accept other functions as parameters. So for example, here, when we're handling the user click, then we get the user and the action to be triggered. So what this function is, this handle user click, is a high order function, which is our first keyword. Let's call it keyword. The first keyword in our vocabulary. So in general, functions that accept other functions as parameters or return functions are called high order functions. So now that we have our user click, let's say that we want to somehow bind the user. So we're saying whenever we get the user UI model, then we set the name to the text view. And then whenever we click on it, we call this handle user click. Let's say that this handle user click is also being called from multiple places. Maybe we have multiple UIs that also have to do this to handle a user click. Let's see what's going on under the hood in the decompiled Java code. So under the hood, what we are actually doing is just calling this handle user click function. That's all. But what if we change things a little bit? Instead of using the UI model that we get, the action from the UI model, let's just say that we want to define that action right here when we're implementing the handle user click, so as a lambda. What changes? So in this case, actually, the Kotlin will generate this. You'll see this in the Java bytecode as function1 null instance. This doesn't say much, I know. If you look at the bytecode, which I don't want to show you, what actually happens is that it creates a new function, so a new object. So this means that every time you're passing that lambda, you're creating a new extra object apart from all the other objects that you're anyway creating. So how do we make sure that we're not creating this extra function, especially if handle user click needs to be called from multiple places? Well, the solution for this is inline. When we're marking a function as inline, the code just gets copied. So our handle user click will actually look like this. We can see that the code that was implemented in the handle click has just been copy-pasted, pretty much, in the on-click implementation. And then if we're passing a lambda and we still have an inline handle user click, then again, we can see that the body of the handle user click is copied, and then whatever we passed in the handle user click is going to be put inside the if method. So instead of creating that new extra function, we're just copying the code from one place to another. So no extra classes or objects get to be created by just using inline. OK, but let's say that we have our handle user click, but we want to do something more with the action. Let's say that we want to store it in a variable, that we want to use it for something else. Well, we can't do this, actually, because inline functions can only be used when you're calling or passing other inline functions. But you can't store inline functions, which makes sense, because in the end, you have nothing to store. The Kotlin wouldn't know what to store because it just tries to copy-paste to move code from one place to another. So if you do want to store that function, what you need to do is to use no inline, which is our next keyword. I hope you paid attention, because it's quiz time. OK, so we have our inline handle user click. Let's get the user that gets the user and the action. In the bind user, we have we are calling handle user click, and inside we call return. What happens in this return? Where will it return? To the bind user, OK. Any other options?
Return only to the handle user click.
OK. Let's see what happens. If we would put return at handle user click, then it will return to handle user click. But indeed, it will return to the bind user. OK. What if we have the handle user click inside an on-click listener? What will that return do? Are Brazilians shy? Come on. I heard an option here. OK. Return is not allowed, so it will not compile. So if it confused you, it's good, because the compiler would be confused as well. Return is not allowed here. But what you could use is either return at handle user click or return at set on click listener. So why is this? Let's see the decompiled Java code. So because we're setting that on click listener, we're creating a new object. So just return wouldn't know where exactly to return. We have to specify exactly, do we want to return at handle user click, or do we want to exit completely the new on-click listener? So this is why just return doesn't work. OK, so this means that because our code gets copied and because now we get less objects being created, we should inline all the things, right? Right? Well, yes and no. So yes, if you're taking a lambda as an argument. But if you're not passing a lambda as an argument, then actually there's a low performance impact. Even more, your IDE will tell you that, hey, if you just, I don't know, have an inline of a function that gets a user, it will say that there is no actual performance impact, that you should only use it when you're passing a lambda. And you should use it for functions that are small. So the thing is that because this code gets copied everywhere where this function gets called, it means that you end up with more objects being created, with more work being done when you don't really need it. Even more, if you look at some of the Kotlin standard library implementations, you'll see that the keyword inline is always used for functions that are really small. Most of them are just a one-line or two-liners, but really small. OK, so we've learned what a high-order function is, a function that gets another function as a parameter or that returns a function. And we've also learned about inline and how it saves you the object creation, and how to use no inline when you want to store a function. So if I haven't said inline enough, I will say it more. Inline classes. So first, a warning, inline classes are still experimental, so chances are in the next release of the Kotlin, what I'm telling you now might not be valid. But for now, it still is, I promise. So in one of our sample apps, we had something like this. We had the list of comments. We can post a comment to a story, or we could post a comment to a reply. But if you look, these two functions look pretty much the same. So they both get like a string, long, and long as parameters. The difference was actually that in one, the ID was supposed to be of a story, and in the second one was supposed to be of a comment ID. But there's no actual differentiation between them. You can, because they were both in the same class, you can easily just call the wrong one by mistake. So one way to do this, or the goal would actually be to strongly type these, to make sure that you're not using the wrong one. So instead of just holding a long for the story ID, to actually hold a story ID. And similarly for the comment ID, to store an object that's comment ID. So one solution is to just wrap the story ID. So you would use probably a data class that would just be a wrapper for that ID, and you would just pass that one forward. But the problem here is that for every time you need to work with a story ID, you have to create a new object. So you have this extra object creation that happens. Well, the solution for this are inline classes. So like this, you avoid that extra object creation. So let's find out more about inline classes. So what I like about inline classes is they really enforce these best practices of like, hey, the role of inline class, what you actually want is to wrap one object. So inline classes have a series of limitations that really enforces this best practice, this idea of a wrapping. Because you're not allowed to have more than one parameter for an inline class. You're not allowed to have backing fields. You're not allowed to have init blocks. You're not allowed to extend classes. But you can inherit from interfaces, and you can have properties and functions. So for example, we can inherit from an interface ID and create our class. So what's going on with inline classes? What's the magic behind them? Well, actually, they're just final classes, as most Kotlin classes that implement that ID, that would have the ID that we passed as a parameter. But the difference is that it allows us, it exposes both the ID or as a long or as a boxed version. So you'll see that it exposes a story ID object. So by default, it will automatically box that long ID that we've passed there, and it will create a new object for it. So this means that when you're using an inline class, the object, so in our case that ID of type long, is either represented as a wrapper or as a long, depending on the case. It will be boxed when it's used as another type. This sounds vague. What does that mean? So for example, let's say that we have our function called doStuff that gets a story ID as a parameter. Well, in this case, we can see in the decompiled Java code that it just uses the long, so the object that's being wrapped. That's all. There's no extra object creation. But if, for example, we want to get the actual ID from that story ID and we just need an ID, In this case, it will be boxed. So it will be used as an object. So a new story ID object will be used in this case. You know how I told you it's going to be a quiz? Well, I lied. There are going to be 2 quizzes. So let's say that we have a story ID. Let's see whether our story ID will be boxed or not in several cases. So let's say that we want to use that story ID inside the list. Will it be boxed or not? Hands up if you think it's going to be boxed, auto-boxed. OK. Congratulations, you're right. So because collections expect an object, then automatically Kotlin will know that, OK, if I need an object, then I have to create a story ID, an actual object, not a long. OK. What if I have a nullable object here? Will it be boxed or not? Yeah. Yes, nullable objects are also boxed. Because it's nullable, then it will create an auto-boxed. OK. What if I'm using an any? Auto-boxed? Well, any, it's also an object. Therefore, it expects an object. Therefore, it's going to use the boxed implementation. So in general, auto-boxing happens for nullable objects inside collections or arrays, or whenever an object or any is expected. OK. If you think we're done, we're not done. How about equals? So we have a story ID 1, story ID 2. What happens when we do this, when we do s1 equals s2? Will it be boxed or not? Yes. Well, under the hood, what's being used is an object equality check. So this means that because it expects objects, these will be auto-boxed. How about this one? S1 equals S2. You're saying yes, some of you. Yes, for what? For S1 or for S2 or for both? So actually, in this case, just S2 is going to be boxed. S1 won't. Because because inline classes have their own equals implementation, and there it will keep the S1, so the object it's equals is being called on based on its value, so it won't use the wrapper. But because equals accepts an object, then that one, the S2 in our case, is going to be boxed. So be careful when you're using CL classes, when you're using inline classes. I'll talk about CL classes later. OK. So when I showed you this do stuff, I didn't actually cover this magical characters there. So what is actually the compiler doing there? So the compiler is mangling the function name. So here's why. Because we could actually call the same or have the same function name, but in the same class, but once where we're passing the story ID and once where we're passing the long. So the compiler needs to somehow know, OK, which function do you actually mean here? Do you mean the one where I'm using the wrapper or where I'm using the actual class? So to make this differentiation, the compiler will mangle the function name when we're using an inline class. So the consequence of this mangling is that inline classes can't be called from Java because that kind of schema won't be able to be interpreted by Java. So the problem with this is that if you're in the process of migrating your code base from Java to Kotlin, you have to be careful because even if you would want to create an inline class from one of your classes, if that class is still being used in Java, then you have to wait a bit, and then wait until all of your code base that uses those classes are indeed in Kotlin. Okay, so inline classes. They're good. They're creating good principles, this idea of wrapping. And I like that the compiler is the one that's enforcing us all of these best practices, that it allows us to not make mistakes. That it's not just based on us and our human error to spot when we're doing more than we should. But also keep in mind that inline classes can have unforeseen consequences, especially when you're using them as objects. Okay. Next one will be seal classes. So seal classes are used for representing restricted class hierarchy, where a value can only be one of the ones from a limited set. So more precisely, you can only define so practically the seal class is like an abstract class, but it can only have implementations in the same file. So let's say that we have a result class, and we have a success and an error. We know that these are the only available types for result. It can't be anything else. So whenever we're using it, we want to make sure that we're also covering all of those cases. So right now, we would probably use a when and check if result is success to something, if result is error to something else. But what if we want to have this enforced by the compiler? What if we don't want to rely on us remembering to add things? What if I'm defining success and error, but then someone else defines also an in progress, but forgets to add in progress to all the places where this when check is made? Well, to do that, to have that enforced by the compiler, we would have to make the when exhaustive. So the when, to make when exhaustive, we will have to use it as an expression. So we would want something like this, to say when as exhaustive. Here, it looks like almost like dark magic, but it's not that much. What actually we've been doing here is we're creating an extension property on T on any object where we're just returning it. By doing this, we're treating the when as we're making the when exhaustive because we're treating it as an expression. And like that, if we're having something like, I don't know, we commented out something, then the compiler will tell us, hey, implement all the branches. So seal classes feels something like magic, right? The compiler just magically knows that these are the only options that we've defined, right? So subclasses from seal classes don't necessarily need to be nested. They just need to be defined in the same file. So for example, in my seal class, I can have a data class, a class, object. We can have any type of seal class. And they also accept hierarchies. So you can have a seal class that extends another seal class. So what's going on? What's the actual magic? So what we see is that the compiler creates indeed an abstract class, but the key, let's say, is that synthetic method. So you'll see here a constructor that gets that default constructor marker. That default constructor marker is something that's specific only to the Kotlin compiler, and only it can use it. So practically with this, it enforces that you're not creating classes anywhere else in other files. But the rest, it's the same. It's a class that extends that seal class. There's nothing else that's special. And then once we get to the implementation of that class, we see that that default construct marker constructor is being called. And if you would call this from another file, it wouldn't know how to find this, this constructor. OK, so what happens with our case? What if we have a when? How does that decompile code look like? So let's say that we have our function that gets a CL class, and we're just going over each state. So in the decompiled code, we're just getting the state. And the when, it's just a series of if-else, and that's it. Where in the last case, we're throwing or the compiler throws a no branch matched exception. That's all. So what's the magic with exhaustive? What's happening here when we're treating it as an expression? So what's the compiler doing? It just creates a unit that's instantiated for every branch of this if-else. And then at the end, it just calls our getExhaustive. And then if one of the branch would be missing, then that var wouldn't be instantiated. So that's what makes the compiler complain that, hey, you're missing a branch. OK. That was enough with CL classes. Let's talk about collections and sequences. So in one of our sample apps, we had something like this. We had a list of comments that you could add replies to, and you could add replies to replies, and replies to replies, and so on. But what's interesting is actually how our API looked like. So we would get the comments based on the IDs, and we would get as a response a list of comment responses. In this list of comment response, we would get actually links to all sorts of other properties of a comment response, which is also the list of comments that were added as a reply to that comment. So overall, when we wanted to get the comments for this story, we would get first the top-level comments, and then get from the comment responses the links to it, and so on for every layer. Then we had to match them based on parents, and we ended up doing a lot of list operations. But fortunately, with Kotlin, we didn't have to implement a lot of these functions, because Kotlin collections expose a series of extension functions. So things like group by or map. These are things that are by default implemented by the Kotlin standard library. So if you have to do some extensive work with collections, first check whether actually what you're trying to do isn't already implemented. OK, collections. When you think about collections, what happens here is that every operation on collection is being eagerly executed. But is there a different way? And yes, the Kotlin library also allows working with sequences. So let's see exactly what's the difference between collections and sequences. So overall, the difference is that one is evaluated eagerly and one is lazily. So let's see. Let's say that we have a collection of shapes. And what we want to do first is to make all the shapes yellow. And then we want to get the first shape that is square. So let's start with collections. It will first go with map. So it will create a new collection where each item is now yellow. And then it will go with the shape. And then it will try to see, OK, does the first element of the collection matches the shape I'm looking for? No. Does the second one match? Yes. So we stop here. What's the difference with sequence? With sequence, instead of converting the entire list, we're working on each element on the row. So first, we're getting the circle. We're making it yellow. Is this the shape that we're interested in? No. Next, we're going to the square. We're making it yellow. Is this the shape that we're interested in? Yes. So the difference between collections and sequences is that in sequences, the elements are evaluated one by one. So in our case, we didn't care about these last two elements, and we didn't even get to iterate through them, because we already got to our element. Whereas on collections, each operation is executed on the entire collection. And even more, a new collection is created for each operation. So consider that you have a very big list a very big collection. What does that mean? It means that you end up creating a copy for it every time you need to use it. Okay. Whereas the sequence doesn't work directly with the collection, but rather it stores an iterator on the collection. And then we have here we have two operations, the map and the first. The first is called a terminal operation, because actually only when you get to a terminal operation that will trigger the execution of all of the intermediate operations up until the terminal one. So let's see what's going on under the hood. Let's see how the map function looks for both collections and sequences. So for sequences, we see that in the map, we just get a transformation, and we're returning a new transforming sequence. That actually just gets the current sequence and the transformation. So practically what we're doing here, we are storing that transformation, that function that we're passing there. Whereas with collections, here we can see that we have an inline map where we're creating a new array list based on the collection size, and we're passing the transformation to it. So we can see that indeed the object is, or the entire collection is being copied. But the main, or one of the interesting differences is this inline, the fact that the collections are inline functions, whereas sequences are not. So if you remember from 20 minutes ago, the reason why we can't have sequences map inline function is because we are storing that transformation there, because we're passing that function to this other object. That's why we can't have it as an inline function. So overall, collections or sequences, which one should you use? I would say that if you have a large number of elements, then you could use sequences, especially if you have a lot of operations happening on them, because then you would only store the functions. But if not, you would use collections. In practice, things maybe are a bit more subtle, because it depends a lot on how large your collection is, what kind of objects do you have there, and whether copying a collection is indeed more safe or more or less expensive than creating or storing a bunch of functions for sequences. But I would say that this would be an overall idea or an easy way to think about these things. But wherever you end up using collections or sequences, both of them have a lot of extension functions implemented. So whenever you work with them, make sure that you first look at what's implemented already for you and don't try to reinvent the wheel. So we looked over a few Kotlin vocabularies. We looked at what high-order functions are. We looked at inline, both for functions and for classes. We looked at seal classes, and we talked about collections and sequences. So that was all from my side now. And this time is a quiz time for me, because I'm hoping you have questions. Thank you.
Does anyone have questions? It's working? Yeah. I would like to know the difference between the inline classes and type alias, and when I should use one of them.
Inline classes do more than type alias. With type alias, you're just saying use this as this. Whereas inline classes do more magic, right? They are doing that boxing thing. So I would say use inline classes for exactly for this, for being a wrapper, a small or a wrapper over an object. That's all. And then for anything else, use type aliases.
Thanks. Okay. Hi. Is it harmful to use sequences in smaller collections?
if, for instance, I'm not sure if my collection is going to be this large, it's harmful to performance or anything?
So in the end, sequences are just storing functions, right? So, and if your collection is small, I would say that you could use collections. The difference might not be that big, but it also matters what you're storing actually in that collection. If your objects are actually really big, then you'll end up copying each object. I don't know. It also depends. It depends on multiple things, because it depends also on the number of operations that you're performing. So here I just showed a map. Actually, on my example with the 4 shapes, probably the performance is very similar between collections and sequences, because I only have 1 operation. But consider that you have, I don't know, 10 operations on a large collection, then you might end up having a problem. So for small things, it might be the same. It really depends on a case-by-case basis.
Thanks.
Sorry.
Hello, welcome to Brazil. I want to ask if I can use inline classes with generics, like using one type argument.
As a generic, you mean, or to pass like your ID to be a generic? In my example, I used a long. You want it there to be a generic?
Yes, for example, like.
I haven't tried it, actually. I would expect so. Can you try it and then tell me?
Okay.
I would be a worse thrower. Thank you.
You mentioned inline functions and the no inline keyword, but we also use sometimes the cross inline keyword, and that wasn't mentioned. What is the difference that it makes?
Actually, I avoided that on purpose because I couldn't find an actual rule when I need it, except when the compiler tells me to.
Yeah, that's what I followed.
So I only use it when the compiler enforces me to use it. I tried reading about it to understand if there's a rule. I asked even a few folks from JetBrains, and it sounded like when the compiler tells you to use it, use it. Sorry.
Fair enough.
Okay.
5 points for throwing.
Thank you very much for this talk. First, when I use sealed classes with an when, Android Studio usually tells me this should be exhaustive. So it was really new to me to see you talking about the exhaustive keyword, I think. So is like if I ignore Android Studio, the project will compile? Because I have used it in the very same example you placed it for us, and I was like, okay, I need to make it exhaustive by default without the exhaustive dot exhaustive.
I think it really depends on how you're using it. Because, for example, if you do return when, that already transforms the when in an expression. Or if you're doing val, my val equals when and something, that's already an expression. So.
Okay, now I was using attribution. When with attribution, yes.
Yeah. So when and if they become they can be used as expressions, right? And then in the case of when, it will become exhaustive.
Okay, thank you.
Hi. Well, actually, it's not a technical question, but I want to ask about your opinion about functional programming, because we are in a hype of functional programming. And what's your opinion? Should we be very strict in our applications using Kotlin as a functional app or not?
I have to say I didn't use like strictly functional programming. I do like the functional constructs that Kotlin brings. So the fact that you're able to create functions, to pass functions around. And I really like this idea that a function should be a unit that doesn't have any other consequences outside it. So I think these in general are very good principles to follow. But
what about using only constants and not variables, you know?
What do you mean? Like top level?
Immutability, you know. Like
Oh, yes. Yeah, immutability is definitely one of the principles that I really try to use. I think it comes in the end from the same idea of the function, right? If we're saying with the function that it shouldn't have any other effects outside those lines, it's the same with an immutable object, right? It means that no one else from the outside should modify it. So yeah, that's also something that we've been trying to follow also in our samples and stuff. Yeah.
Oh my God. I have one last question, I guess, because we have out of time. Regarding that new, when you pass the parameter inside the when from the Kotlin 1.3,
Yeah.
how that responds to the exhaustive stuff? Is that
I'm not sure I know what you mean.
there's the new way to add values to when statement when you in this new version of Kotlin 1.3.
I don't think I know of that.
Okay. Yeah, you can assign a variable inside the when.
Oh, yeah.
Yes. Is that okay for the exhaustive stuff? So it doesn't affect
I haven't
it?
tried it with that. Yeah, I've seen that, but I haven't tried it with still classes.
Okay. You can try. Okay. That's it. We are out of time right now, so I want to thank you, Florina, for this amazing talk. I think we can have applause now. Do you want to say something? Do you want to say something to Brazilians and people that's here now? Sorry.
Thank you for coming here and talk to me. Tell me where you use Kotlin. Tell me why you're not using Kotlin. I'm sorry that we don't get to come to Latin America or to Brazil specifically as much as we would like to, but I know we do care about you. So tell me your problems, specifically related to Kotlin, and
not Java 1, please.
and then because I want to help you, but I can only help you if you tell me what kind of problems you've been running into and so on. So I'll definitely be here until the end of the event. So come talk to me. And the workshop is really for beginners with Kotlin. So if you haven't played around with Kotlin at all, it's going to be for you. If you already know actually everything that I've been talking about here in this talk, don't come. But still talk to me, please.
Yeah, actually, I want to reinforce that this is a very unique opportunity to talk to Florina because a lot of people here cannot go to like Google I/O or like outside Brazil to conferences. So this is a very huge opportunity to have a developer advocate from Google here, especially Florina, which is one of the best persons that I ever know. So thank you and applause. All right, switching to Portuguese. Gente, bom, incrível, né? Aproveita a oportunidade para falar com ela aqui. Ela está acessível, está o dia inteiro aqui. Também espero que a gente tenha no fim do evento também um papo sobre mais coisas sobre Android também. Agora vamos ter um talk de ninguém menos que Nelson Glauber. E tipo, grandes. Tipo, gente, lembrando, divulguei lá no Twitter, a gente está ao vivo, tá? A gente passou o link do Meet desse evento aqui ao vivo. Outro aviso também importante, a gente vai ter sorteios no final. Quem chegou a ver aqui, tem um monte de brinde na mesa aqui, tem caderno, tem garrafa, tem um livro dessa pessoa maravilhosa. Mano, olha isso. Tem a Bíblia.
Ajuda a malhar braço também.
Olha só. Vamos ter sorteios no final do evento, então quem quiser ganhar brindes aí, temos camisetas, copos, garrafas, E 3 livros, né? Esse aqui, que é o do Glauber, de Kotlin. Temos também o Kotlin em Ação também, uma unidade, que é também traduzido pela Nova Tech, né? E também temos um da Pact que é Programando com Kotlin. Então, além de várias coisinhas aqui, então fiquem por aí. Então, para continuar aqui o evento, vamos ter agora o talk do Glauber, que é sobre Android e coroutine. Então, Glauber, palmas aí, gente, para ele.
Bom dia, pessoal. Muito feliz de estar aqui. Não tão feliz porque meus slides apagaram. Bem, é um prazer enorme estar aqui em São Paulo. Eu fico muito feliz de estar visitando aqui a cidade de vocês, vim lá de Recife, para falar para vocês um pouquinho sobre Kotlin e sobre Android. Tá?
Glauber, acho que está dando problema aqui no vídeo.
Tá, não, beleza. Enquanto está transmitindo, a Florina falou que vai ter o workshop dela. Quem tiver... Eu vou estar por lá tentando ajudar um pouquinho, tá? Então, quem tiver interessado no workshop, eu vou estar lá para ajudar, ok? Vamos ver se volta aí os slides.
Glauber, você consegue plugar, tirar e colocar de novo, por favor? Espera aí, rapidinho. Oi. Tá. Quem está participando do workshop, por favor, vá lá para fora, que a gente vai acompanhar o Ivo para poder sair e, de fato, ir para outra sala da Ayrton Senna, que é para você poder fazer lá embaixo, no outro andar, tá? Então, acompanhe ele, que a gente tem que estar com alguém do Google aqui. Agora